Okay, let me introduce our project and demonstrate how it works. First, let me give a brief overview of our project structure. The financial phrase bank folder is used to store datasets. The outputs folder contains all of our visualization files, like this. The save the model folder is to save our model files. The loss function files writes down all of our implementations of the loss functions. The model file writes about our model. The train file is used for training model training. The visualization file is to produce the visualization images about training, loss training process. The visualization extra file is used to produce additional visualizations. The rest of the Py files are utility classes like TZT2, CSV, early stopping mechanism, and contain count len, maxi len, and the benchmark results. Okay, next I'm going to talk about the two Py files, train and model, which are our model and training files. In the meantime, I will be running our project as it will take some time. Okay, let me introduce the model Py file. This model architecture builds on Distil Bert with three optimization. First, our dataset class pre-computes all text encodings during initialization, eliminating redundant tokenization during training. Second, the orthogonal weight initialization ensures faster convergence compared to default settings. And third, the AutoCast wrapper enables automatic mixed precision training, boosting GPU efficiency without sacrificing accuracy. The data pipeline handles CSV loading, label conversion, and reproducible dataset splitting using PyTorch's random split with manual seeding. Enables automatic yeah, notice how the prediction function maintains consistency by reusing the training tokenizer and automatically detect available compute devices. Okay, let me introduce critical implementation details. Uh, the the CLS the forward methods include the C the CLS token extraction for sentence level embeddings and drop out configuration set at 0.3 for optimal regularization, and the sentiment mapping dictionary converting numerical outputs to human readable labels like positive, negative, and neutral. Uh, and for training configuration, we use a maximum sequence length of 315 tokens to preserve financial text context, while the prediction function operates at 128 max tokens for real-time efficiency. The validation split ratio is set at 10 percentage to balance evaluation reliability with training data volume. Okay, so let me introduce the training pipeline. Let's examine our training pipeline, starting with configuration. So here is the global configuration of our project. The central settings block defines hyperparameters like loss function, learning rates, patch size, epochs, and others like early stopping mechanism and random seed output directories. Uh, and okay, I will introduce the next part. Here, the function is to ensure the output directory exists, and here is our core train file and train logic. Firstly, we detect the uh, device so that we can automatic change the device to CUDA or CPU, and we try to split out the train dataset and the value dataset, and to create a model implementation to use a specific loss function from the configuration. And if you want, you can open the early stopping mechanism to uh, prevent the overfitting. And here is our training stage. uh, like here is attention mask, here is label, and our optimizer use the zero grade. We optimizer use the atom w. Yeah, here is to do a initialization, and after that we use the prediction we to use the get loss function to get the specific loss function. And now uh, we use the cross entropy. Yes, and here is our backup propagation. Here is the evaluation stage. uh, Validations phrase phase checking compares train value accuracy gaps to prevent overfitting. Our visualizer updates metrics in real time, generating live updating loss or accuracy curves. Uh, here here we will save the visualization results. And here is our main function to order the sequence of the training and the validation and the visualization. And we implement a a special function is that we can uh, automatic to detect what is the hyperparameter is the least form, so that we can just only uh, round round one round, so that we can get uh, get output like this different learning rates here. Okay, uh, so here is our yes main function. Okay, after finishing the after finishing introducing the train pipe file, I will uh, introduce our visualization part, since you can see that our project has already been completed. The result has been saved as here. Okay, so from the result uh, we can it can be seen that the line graph of training loss and the validation varies with the number of epochs. We use the control variable method, which means adjusting only one hyperparameter while keeping the other hyperparameters in unchanged to see how much impact a certain hyperparameter, such as learning rates, has on training under the same configuration. Here we give four different learning rates, and here are the four different curves of the different learning rates. And this is training accuracy, this is training loss, and this is validation loss. Okay, so we also there is also benchmark result. We shows that here is precision record and F1 score support, uh, and we can see that the result, the performance are basically higher than 90 percentage, showing good performance. And the last one, the visualization, is that comparing the results of the first 100 predictions, it is clear that only a few of the 100 predictions are incorrect, and the vast majority of the samples are correctly predicted. Okay, so if you would like to see the detailed introduction of the project, please refer to our report. Our report details the project are written down in detail, including the analysis and the screening of the dataset, rationale for choosing the model, analysis of the training results, and much more. Thank you for watching the video.